for Mercury, which is a GEO flagship program. Okay, you can go to the next slide, please. Oh, I've got this thing over here. Okay, so as most of you know, there's about 4 GEO flagship programs, GEO Bond, GEO Glam, most of you know that, and then there's GOS4M. It stands for the Global Observation System for Mercury, and the main idea basically behind this GEO flagship program is is to integrate several operation network into one large infrastructure in terms of data. Also, the network is established in gathering the availability of data into one central platform. So that is just the basic idea behind this. And if you look at the 2022 work program, you will see a definition of what the GEO flagship program is. And it's basically an initiative by GEO to see how we can impact global, national, and local decision-making. And this is what GOS4M is currently doing. In terms of our main scope, we aim to support the UN and the end users in terms of the Minamata Convention on Mercury. The Minamata Convention on Mercury is the latest multilateral environmental agreement that was signed by 138 parties. It came into force in 2017. So it is the latest, as I said, the latest convention. Others are like, you know, the Montreal Protocol and all that other stuff, the Stockholm Convention. So the Minamata Convention is basically the baby out of all the conventions that is currently out there. So in terms of who we are, most of you will know the chairman of GOS4M, Nicola Peroni. He's also the GEO principal for Italy. And he has been one of the main voices in terms of mercury monitoring globally and also within GEO. And then we've got 3 other coaches, Su Shao from China, Sandy Stephen from Canada. I'm also one of the coaches and also the vocal point for Africa. So that is just the basic structure how we work, and there's about 21 partners currently part of GOS4M. So in terms of mercury, what is the issue? Here's basically the issue. Mercury is a global pollutant. It has got several side effects, very toxic, it's a neurotoxin. And if you look at the definition it's given in the Minamata Convention on Mercury as to why we want to monitor it, it's basically it's danger to the environment and also for human health. So that's why there is something called the Minamata Convention. So what is the real issue? Here's the real issue. Once mercury is released into the atmosphere, it undergoes several reactions, oxidation, reduction reaction. It gets deposited by a wet or dry deposition into the water, into the soil. There it's bioaccumulated, methylated, and eventually it comes up in the food chain. And we as human beings are mostly exposed by eating fish, which is contaminated with mercury. So that's why it's a big concern, not only locally or continentally, but globally. And that's why it's called a global pollutant. In terms of GOS4M, we've got 5 pillars why it's important that we are in existence. And basically, number 1 is focus on knowledge collection. That's where the monitoring comes in, knowledge formulation, knowledge sharing. That's where the end users comes in, the mercury community is involved, knowledge use, and very importantly, knowledge generation. And this is where we want to influence policy, or at least guide politicians when it comes to legislation and also to decision making. So these are the 5 pillars, which is very important for us as a flagship program. In terms of what is currently happening, there is a global network of networks that's either national or it's either continental. but these are more or less some of the main players in terms of mercury observations, and most of them are contributing to GOS4M, their data as well. So if we shift the focus from the global perspective and we shift it to Africa, you will see this was taken from the Global Mercury Assessment, which is an assessment done by UN every 5 to 6 years. All the dots on the graph indicate where mercury observations are taking place. And if you draw a line and you divide it by Northern Hemisphere and Southern Hemisphere, you will definitely see there's an imbalance. And if we focus on the African continent, you will definitely see there's not a lot that's going on there. For many years, the station at the bottom at Cape Point has been monitoring mercury continuously since 1995. And so we were, for many years, the only active station monitoring atmospheric mercury. So because of this imbalance that we saw and the shortage of data, South Africa's contribution towards the global observation system for mercury was that we established the South African Mercury Network. It was established in April 2020. So when everybody in the whole world was going down into lockdown, I always say we kicked it up a notch and decided to start a project, which wasn't the best of ideas, but anyways, the show must go on. And I mean, despite all the challenges with COVID and as you know, companies closing down, trying to order stuff, trying to set up new collaborations locally and overseas, it was challenging, but I'm happy to say that we've definitely made some great progress in the past 2 years, which the South African Mercury Network has been ongoing. So Cape Point, as I mentioned earlier, was for many years the only site in South Africa that monitored mercury. And since April 2020, we were able to establish 3 more ground-based sites. So this is sites where instruments are placed and where we monitor atmospheric mercury, high frequency, so we have a reading every 5 minutes. So that's where the instruments are placed. Okay, how do I go back? We were always also able to set up a passive sampling network within the country. We've got 9 new locations. We were also able to establish a wet deposition network throughout the country. So all this was done while everything was in lockdown. And in May this year, we also started with speciation monitoring at Cape Point. This wasn't initially part of the project, but we also, this July, we started with observations over the Southern Ocean, where during the winter cruise, one of the instruments was on board the South African, the SA Agulhas, the icebreaker that went down to the ice in Antarctica, following the purple line over there. That's the Good Hope Transit to the ice in Antarctica. So we did atmospheric mercury monitoring from Cape Town down to the ice in Antarctica. And we also took water samples along the way. So we are definitely planning on repeating this as the winter cruise is happening every July. So we will definitely send out another team to do this type of monitoring again. The blue dots, which you will see, it's part of the Global Passive Network. It's an initiative that was started by Environment and Climate Change Canada in 2019. And the green dots, which you will see there, is some of the new stations which we have started through SAMNET, the South African Mercury Network. We were able to start 2 new sites in Ghana, in Guyana and Kenasi, and these are the other sites which we started this year in July. So the picture on the African continent in terms of mercury data is, it's looking a bit better. From one side, we are at least getting more sites where we can get some data. So the whole idea is what can we do with the data? Why do we want to do it? And basically, if we, as I've mentioned earlier, our main link is to the Minamata Convention on Mercury, where Africa as a continent has been identified as a data scarce region together with South America and Southeast Asia. So we're definitely trying to improve that picture, identify the data gaps and weaknesses of the current system that we have in place. but also provide a platform to develop products to support the science questions. So that is basically what we want to do with all the data, and we make use of the knowledge hub that is available for us. I think it was mentioned several times yesterday and this morning again that, and it's actually an African proverb that said, if you want to go fast, you go alone. If you want to go far, you go together. And if we want to improve the situation on the continent, we need to go together. And there's a South African artist, her name is Vicky Sampson. She has a song entitled My African Dream. And this is basically my African dream for us as a continent, that we will be the first continent that will have a coordinated continental mercury network. We have shown with SAMNet that through the small pilot project, if we can duplicate this in North Africa, in East Africa, in West Africa, we can definitely be able to get a continental, African mercury continental network going, which then can provide data to GOSFOM, and ultimately the data be available to our policymakers when it comes to the Minamata Convention on Mercury. So my take-home message is this, is that there's a lot of new research ongoing in Africa, and it's good, it's really encouraging, but we also need to look at the realities as well. We need to improve our monitoring capability as a continent, so we need data first of all. We need to fill in the gaps to give us a better continental view. In a discussion I had with some of the people that attend COP meetings, they say when it comes to monitoring and the effectiveness evaluation as a continent, we can't take part in the conversation because we don't have data. So we are relying on other parties to guide us as to what we do. And we really want to see that this situation change. The Executive Secretary of the Minamata Convention, Monica Stankovic, mentioned this during the recently held ICGMP conference, is that research should lead policy-making decision. And for the Minamata Convention, that's definitely true. There's a lot of research that has been done over the years, and that is the reason why the Minamata Convention also came into force. There's definitely a need for us as a continent to work closer together with the Minamata Vocal Point, with the Bureau, and also with our AfriGEO members. Then just finally, in terms of the stakeholders and the sponsors that is involved with the South African Mercury Network, these are all the partners and the funding agencies, the Department of Science and Innovation in South Africa, and they've basically made this possible that we were able to start this initiative, this pilot initiative, which have shown that if we continue, we can definitely gain momentum and definitely do something in Africa. Okay, thank you. I hope I stick to my time. Thank you.
Thank you very much. Thanks for keeping to your time. So the next presentation is on forest mapping in Gabon by Francis Manfobi. I hope I've pronounced your name well. Introduce yourself in one sentence and then go to the presentation.
Good morning, everyone. I'm Francis Manfobi. I come from Gabon. I work for Space Agency, Gabon Space Agency. I will to present the mapping of forest to Gabon. This is the outline to our roadmap. Wow. Take. So it is important to know that the Gabon is covered by plus 88% covered by forest. For this percentage, it is important to put in place some methods and policy for a better management of this forest. That is because the space agency, Gabonese Space Agency, is created in 2010 to the better management of forest. The main mission of this agency is to contribute to the implementation of government policy on the collection, analysis, and availability of data from spatial observation of national territoriality for the sustainable management of environment, natural resources, land use, regional planning, and research and innovation. We are this agency has a specific mission, such as develop a national strategy for space observation activities, establish a space infrastructure, or promote training, research, and development activities. In AfriGEO, we have two big parts technical. The first part is the ground station, direct reception station. And the second part is a competence center for satellite data provide. About a ground station, we have a big field of antenna. For example, X antenna for radar data and optical data reception. We have S antenna, S-band antenna. We have also antenna for acquisition of meteorological data, and the last antenna is a GMS antenna. About for forest, it is important to know that the main role of AfriGEO to monitoring management of forest is correct. The decree 00474 of the First Minister, which set out the modality for monitoring activities that have an impact on forest. So, the First Minister take a decree to give an AfriGEO the first role to monitor the forest of Gabon and put all information, deforestation, degradation, and regeneration on forest for all administration, all partners. In same sense, we have a creation of a forestry department with AfriGEO in charge to monitor and give an information to forest mapping. In this forest department, we have is being actually the National Forest and Natural Resource Monitoring System. It is a big system. We can have all partners, forest department, mining department, and NOG stakeholder. The different objectives of this system are the monitoring of forest, detect forest cover disturbance, the analysis of this disturbance, and share all information to forest of with all partners. This is an overview of this system. You have satellite data, field data, and processing segment with all parts to share data, geoportal, decision maker, and partner network. For the better management of forest in Department Forestry, we have developed 4 activities, 4 products and services. The first services is a land cover. The second is a login monitoring. The third is the monitoring of sensitive site. And the last is the carbon and biomass. This last application is not very well developed actually, though, because we are waiting over partner, over a program to help us to develop this application. About land cover mapping, it is important to say that this is application. It is the the main product of AfriGEO to Gabon. This is a picture. It is the first page of the report, the land cover mapping 2020 and the change between 2015 and 2020. In AfriGEO, we have a big forest database from 1990 to 2020. Big database forest, donc forest cover and land cover. And also the different state of change between different dates, for example, 2015 to 2020. This is a state of land use in 2020 with all land use class for main statistic. Here we have a land cover chain map with main statistic. We have a degradation and deforestation. We can see that this is a product. The degradation is a big or big two for the deforestation. This is a different statistic to change in forest. For each type is forest, we have a change. Donc, for example, forest by forest to biosoil, forest to building, forest to low vegetation, etc. This is a conversion of forest by land use. For each type of forest, for example, mangrove, we have the driver of lost. For example, this here we have the mangrove. We have the 44% lost forest mangrove by biosoil. Other example, we can take a mature forest. We have 55% of a lost forest mature caused by logging. So here we have each forest combined with main driver. So I said that this project, it is a big project. It is a big product to do that each 5 years, from 2010 to 2020. Each 5 years, you product this information. So during year, you have many activities to help us to monitoring the forest. For example, you have a logging activity, the shifting cultivation, agro-industry, mining, and urbanization. So this is an example to product and service can give to all partner and all stakeholder to give an information to lost and gain forest. For example, here we have a logging monitoring bulletin. It is a product to get each quarter. Donc in year we have four reports of this type to reporting all lost forest in each concession, in exploitation concession. This is an example to logging monitoring. We have each concession, you have each operator. For each concession, we are lost forest by concession, by operator for all country. So another example is a mining monitoring. Mining monitoring, it is a activity very speed to lose at forest. Here also you are also mining monitoring bulletin for each quarter, donc first quarter, second quarter. For each operator, for each concession, we have the main statistic of loss and gain into each concession and each operator. This is activities to do all year long to monitor and forest. After hand year, we compile all information to put one information and to share with Minister Forest, mining for minister, national park, and so. So AfriGEO is also participate in sub-regional deployment. For example, this GMS in Africa, we also product the main product and service for example, land cover map to country in Africa, for example, Burundi, Equatorial Guinea, and interest zone in Chad. This is a collaboration stakeholder, international and national. This is not exhaustive listing. Not exhaustive listing. So thank you. Last message, Israel, Gabon is a new country in Commonwealth. So because I try speak in English this morning.
Thank you. You've done very well. If it's the first time you're presenting in English, that was very good. Welcome to the Commonwealth. Okay. So I think we are good so far. Our next presenter is Webster Gumindoga from Zimbabwe, University of Zimbabwe, and he'll be presenting on Wetlands Master Plan of Zimbabwe. Welcome.
Good morning, everyone. So I'm going to present on national wetlands delineation, a geospatial-based approach in Zimbabwe. Let me start by saying wetlands are one of the country's vital ecosystems, and they provide ecological goods and services. The loss and degradation of Zimbabwe wetlands has been due to many reasons, but I've just listed some of them. For example, mining and brick molding and groundwater exploration. There's also been rapid expansion of illegal settlements in the urban and peri-urban areas. And we have seen in the recent years, because of climate change induced droughts, but also climate change induced floods, that people have been affected by the fact that they are settling on wetlands, which are low-lying areas. And in the case of floods, most urban settlements have been affected. Okay. There's also been weak institutional arrangements for managing natural resources. You may find that the environmental managers and municipalities have also been to blame for the degradation of the wetlands. But I want to emphasize on the last point, on the lack of knowledge or spatial extent of wetlands, to say that we do not know the boundaries of these wetlands. That's why you see people just settling everywhere, including on these sensitive ecosystems. And so the purpose of this research or a project that we did as a University of Zimbabwe and the Environmental Management Agency and the National Geospatial and Space Agency has been to delineate wetlands across all geographic landscapes in Zimbabwe, also to characterize all Zimbabwe wetlands based on the delineation outcome, and also to develop a geospatial database of all these wetlands, which helps us even now into making decisions for this sustainable management of these sensitive ecosystems. And so what has been the approach? The approach has been to use a satellite product, the digital elevation model of the country that we took and processed in a GIS environment in order to extract some topographic attributes such as flow direction, flow accumulation, and the catchment boundaries. Yeah, so this approach basically is based on the fact that wetlands are geomorphic features. And so if we understand that a geomorphic feature may not change or not change over time. And so this approach, different from other approaches that have been used in several literature. For example, others used image classification, others use indices, but these change over time and also change because of seasons. And so here we're saying, once we're able to extract the topographical attributes of these wetlands, we can separate them from other features that is at the core of this methodology. And so we used an approach called the height above channel, where we are saying in the topographical landscape, are we able to extract wetlands as geomorphic features? For example, we're saying if we know the height above sea level and also knowing the average height of all the rivers, let's say in a certain landscape, we are able to subtract the channel base height from the original DM and come up with the wetland. That has been the approach that we used across the geographical landscape of Zimbabwe. And we just emphasize that we're also able to characterize these wetlands in terms of what to call the headwater wetlands, which means these are the sources that provide the water to the wetlands. And these areas are highly sensitive. And also the middle reach, which is the middle sections. If you take a profile of a landscape or a profile of a river, these are also of medium sensitivity. Lastly, we've got the major rivers, which are the lower sections with the low sensitivity. So that has been the general approach that we used. And also we used a certain thresholding for this wetland delineation. You are quite aware of the straler orders. So each straler order is linked to a certain geomorphic section of the wetlands, to say maybe straler order 1, straler order 2, up straler order, for example, number 4. And we are able to characterize the wetlands based on this in terms of whether they are sensitive, whether they are of low sensitivity. But we're also able to take some satellite image interpretation to be able to, so we generated random points based on satellite image interpretation, so that we could check whether these points that we're randomly generating, do they really fall on wetlands or not, so that would improve the validation of this methodology. So also, because this is an image-based approach, we're also able to go in the field to be able to do some validation across several places and districts of the country. But what has been our results? So for the first time, we now have a national wetlands map of the country. So in previous researches or in previous efforts, there's been just some small isolated efforts, but now we have got the wetlands map, which we divided, like in previously mentioned, into headwater catchments, into middle reach, into also the lower course of the river. Why is that important? Because once someone or once activity such as brick molding, once activity such as illegal settlements, if they are targeted on these headwaters, then we know that we can certainly destroy the wetlands. But also there are some activities that are bound to be prohibited. But what, for example, in our case of Harare, the capital city, you may realize that the city is built predominantly on wetlands. But so should we prohibit development in a so that the city cannot expand? But the answer is basically that it depends on the type of wetland in each and every place under person. So the headwater wetlands, certainly they should be prohibited, but if they're on the lower course of the landscape or on the middle course of the landscape, certainly development can be encouraged. But also to tell you that in this exercise, we're able to come up with provincial district outputs of the wetlands, but so that there's proper management of this critical resource, we are now able to develop a GEO database where there are certain attributes of these wetlands. So let's say there's a developer who wants to develop maybe a more in the country or in the capital city, we are able, the environmental management agents can now go in the database because we provided this as a GIS layer and also other printable layers. So they're able to check on the location of that on that developmental activity and be able to advise to say, look, this place is highly sensitive, or look, this place is of low sensitivity. And so these are the precautionary measures that you can come up with. So it was not possible in the previous years, but now because of this output is possible. But also we have now an interactive web map that everyone in the country, any developer can now access, to say that one can always go to a website and be able to search, if it's my house located in a wetland, is where I want to do an activity, is it located in a wetland, and what type of wetland is it? So these are some of the information from our interactive maps that are now available and that are being used by developmental agencies, the government institutions, and also research institutions. So as I go into the conclusions, very important for me to mention that for the first time, we have a Zimbabwe wetlands map with provincial, district, and local authority sub-maps. So it means that someone can go even into a particular location, pinpoint it, and be able to download the product and be able to use it for research, for any activity or a project. The database for wetlands in the above jurisdiction exists, and also this master plan can be used for integrated wetland management. And the study or this project that was done by the university, the geospatial agents, and the environmental agents, it demonstrates the application of GIS and Earth observation techniques to support national projects. So this just is some emphasis to say that the Web2 or the database or the interactive platform that is also associated with this output, one can be able to search the wetland name, because our wetlands have got names, the boundaries, the surface area, the biotic and abiotic details, and any other details. We're also able to check how many developments or how many houses fall within the certain type of the wetlands. I need to tell you that according to our laws, the Minister of Environment can go into any place and declare any place to be a sensitive ecosystem. So let's say a minister is just driving and then they admire certain birds or admire certain flowers into an area, on an area, and say this is a wetland. They can declare it a sensitive ecosystem and prohibit development. But here is the weakness. Developmental agencies have been at loggerheads with the minister or the environmental management agents, because one would say, what is the basis why a minister can declare a place to be a sensitive ecosystem? But now, because this is now backed by science, backed by GIS, backed by Earth observation, the minister now can win the battles in the courts, because we've provided an output which is backed by science, by GIS, by Earth observation. Who are the collaborators of this project? Of course, the University of Zimbabwe researchers, where I belong to, the National Geospatial and Space Agents, Environmental Management Agents, Scientific Industrial Research and Developmental Council, and several users from the water management boards, academic institutions, and any other person is a user of this product. And I thank you.
Thank you very much. Great work there. So our next presentation is on crop type mapping from CSC Senegal by Adama Sarr. Welcome, colleague.
Thank you, Anastasia. My name is Adama Sarr. I'm from Senegal. I'm working on CSC, Centre de Suivi Écologique. I'm also at University of Gaston Berger as a researcher. I try to explain, to communicate on one services in Seville, West Africa. I choose crop monitoring because it is a relevant point. Can I have my presentation, please, on the screen? Thanks. Next slide, please. Crop monitoring is a pilot project. We are proposing to Seville because Senegalese is a country. We have some ecological area, Sahelian climatic zone, Sudanian zone, and Guinean at the south of the Senegal. What is very important, thanks, for this services is, as you know, we have a regional institution, agreement seals, and each year, this institution provide an early warning system about food security related to some ground data we are collecting in all countries in region in the sales area. We actually propose to move on EO data to improve all data we collect class in the classic field. It's why crop monitoring is very, very relevant in West Africa. As I know, there are not actually currently a system based on EO data for a statistic on crop. It's why I think it is very important to go forward to these services, because the output of these services can improve many things on decision maker. I like this slide, and I thank Dan because I picked up your slide, I think 3 years ago. It's a very big challenge we have between science data and users' needs. My presentation, as you are looking, is very focused on the approach, not for the result. I think the opportunity is USAID, NASA is our two big institutions we are connecting. Thank for that. And to create Seville West Africa, we are in the second phase. And CSA is an institution, national institution, to work on developing many services. The crop monitoring is one of them. We try to cover at the first phase all the entire territory. And as you look on the map, you have some buffer. And each buffer is a study. We are going to collect ground data to identify different crop type, and to with the drone. And in 2019, we are across all the focus sites to collecting ground data. And I like also this, because we try all time to not develop our product in ourselves, because we are scientific, and to put to end users, try to do what you want. We are trying to look at what the end user needs, and we develop product for that. It's why I make more time in this slide. It is a Seville approach. What the name is Seville planning approach. Firstly, we do a consultation and need assessment. It is very, very important. We invite, right now we talk about crop. We invite all institutions, all associations working on agriculture in Senegal at the national level. We ask them what you need currently with EO data, and we collecting many, many information about that. It is the first step. The second step is We look for those who are inviting for the first workshop. Where is the key stakeholder? And why we say stakeholder mapping. And we try to do a screen for all needs that are proposed us to be done. The third level is to try to do a service design. After the second step, the stakeholder mapping, it's at this workshop, we choose to do a crop monitoring. It is very important because it's not our technical or scientist proposal. The proposal comes from the institutions, association working on the ground. And the fourth step is to do a monitoring, evaluation, and learning about all the system. And after this, we are going to create what we call a community of practice, which we are the technical services, which have the association, which have the government services, which have the academic network also. And we develop at the beginning and at the bottom all the services together. And we do each meeting for each time to discuss. It's a very relevant approach, and I try to explain for each presentation what does it mean. The approach is a methodological approach. We try to integrate all we see on the literature, because crop monitoring, I know ICMID in Serbia do well. We have in Mali some researcher, as I know, and many technical approach are proposing in this services. For the ground we try to make with Sentinel data. I think you are familiar on this methodological. Is a simple methodological, is not so complicated, but at this level I think I don't go stress, because our planning, at the beginning we propose to survey is to collect 2 years for ground data, because I think these services need a more ground data to do a serious classification for the image and to have a good model. As you know, West Africa, the farm are so complicated, because we have the small farm, parcel is so, and we mix it many crop inside. So it's not very easy for the image to do a good classification. In 2019, it's our first ground field mission. We have collecting 4,000 point GPS. We go to the parcel and we try to make a GPS coordinate related to each crop. We have a drone. At the same time, the drone fly to take pictures, and at finish, 2019, around 2,000 hectares are being numerated, and it's what we have right now in our database. We have many crops in our region: millets, peanuts, maize, and some parts we have mixed 30% of maize, 20% of peanuts, something like that. It's why we have actually numerizing parcel, and the primary result of the first ground collection data on the field. I think we have some, I don't say good result, but I think hopefully if you have taken another ground data, we are going to improve what we have, and our model is very try to be improved. The same result we have, when we say the overall accuracy, we have a good result. I say technical person can maybe ask him how we have on that. But my last slide is, as I said, we are going for 3 campaigns to collect ground data. We are discussing in Serbia of West Africa for to focus on one region. It is what we say Bassin AfriGEO, Peanuts Basin, to be build a good model before try to upscaling in the entire countries. The conclusion is 3 points. The crop type mapping is the scaling up to cover the entire Senegal, and after you move on the 6 countries, the community of practice takes over the service and ensure for sustainability, because as you know, each country have a technical service to collecting crop data. I think it is very important to talk with them and to push them to take after CSC, for example, in the national level, to go the services and to move on, because it's very important for the government. And the last point is all material tools are made it available, and we work for that. It's my last slide, and I thank you. If you have a question, I'm here for that. Thanks.
Thank you very much. So that we relax our minds a bit, and I'll allow 4 questions we've had for presenters, and make them short, please. Go straight to your question. And so we have one at the back.
Good morning. My name is Professor Sam Patrice from East Estelle, Survey, West Africa, Burkina Faso. My question, I'm French speaker, but we are not in Commonwealth. I have a question to the Zimbabwe speaker. You were talking about wetland, and he made some classifications from the high wetland to the low wetland. I would like to understand the definition of wetland. Soil, humidity, transportation, deposit, vegetal cover. How did you make this classification on high, medium, and low? Is it according to the altitude or the slope? Can we talk about the slope in a wetland? I want to understand what you mean by this classification and how you have made it. This is my question, how you could make that.
Thank you. Another person with a question?
Hi, my name is Ashutosh Limai. I have a question for the Gabon presentation. You mentioned you have land cover maps. Can you elaborate a little how many time slices you have? What are the methods that you use to get to the land covers, and how many ground observations you had? I see that you have desire for expanding that system. So I was just curious to see how many time slices do you have in the past, and what do you have the plans to going forward? Thank you.
Thank you. You've taken note. Okay, so any other person with a question? I want them to answer at a go so that we move a bit fast. We don't want to be too late for our coffee break. Any other question? Okay, two of them.
Thank you very much for your question. Okay. So maybe to start with, so we have defined wetlands as those areas of swampy or marsh that are covered, where the soil is covered by water for a certain period of time. There's to be a sufficient period of time for us to call it a wetland, but also in our definition, or according to the Environmental Management Agency of Zimbabwe's definition, these are areas that are also occasionally being flooded. So we also define them as wetlands. And so why, maybe let me give you a little background of why we had to use the topography to define or to map the wetlands. This because we realize that some areas, if you look at the vegetation and the phenology, they may not look as wetlands. From taking satellite image classification, you may find that those areas, if they are already occupied, if there's already some developmental activities over years, then your satellite image will not pick them as wetlands. But if you go to the original topography, before any development, we are able to really classify the land. So using the DM hydroprocessing algorithms in a GIS software, we are able to classify according to the slope, the elevation, and also some geomorphological attributes, and also to say in this area, are the rivers generated from this area, or they join the mainstream, or they join the mainstream as Strala order, maybe 1 to 4, remember on my illustration. So the software does it for you, but to say that slope, yes, is part of the equation, the elevation is part of the equation, and also the drainage density is also part of that equation. So I hope I've managed to give some little indications to the question.
Okay, the next one from Gabon.
So thank you for the question. The methodology, we used two methodology, two parts. The first part is the classification, automatic classification of satellite data. After we take this result and we make the interpretation photo by operator to improve the difference of each class, each land use class. Yes, thank you.
Sorry, can you speak a bit louder?
Just to remember the wetland that Professor Sam asked, what is wetland?
That's what he tried to answer in the first question. I think you can link up with him after the presentation, and maybe you might want to have more thorough and more detailed explanation.
I want to do a quick comment for my colleague from Zimbabwe, because we work on wetland for last years, and when we do our screen, our scientific literature for different methodology in wetland, it's the first time I see in a methodology we use a DM to make to add value for the result. My question is, have you done a comparative with any DM to monitor wetland, and how, when you use the DM, have you do the are you getting my
He's asking, you're using DM, which has not been used before for similar mapping. How is it applied in the methodology? And have you compared with other methodologies and seen the difference?
Okay, thank you for the question. So here we use a 30-meter shuttle radar terrain mission DM. Of course, just like any satellite product, it needs to be, you need to do error correction. So there's always the vertical exaggeration or center exaggeration that we introduce the cleaning and make sure that it's of sufficient quality before we use it. So here is the DM, we take it. Over years, the GIS software such as AfriGEO, QGIS, they are algorithms to extract those topographical attributes, which is something, of course, if you say of a national scale, it's quite big. Your machine will not be able to run that algorithm. So we used the super computer, high processing computer from our university to run that. But that's basically what we did. First of all, to do the cleaning of the DM first, to remove those artificial depressions, etc. But we can chat further on that one.
Thank you so much. We'll go into the next presentation now. I encourage that you continue these conversations after the session. I'm sure there's a lot that we can learn from each other. So the next presentation is on observation of forest in Central Africa by Luik Kenmu. Welcome.
Okay, thank you for this opportunity. My name is Loïc Kenmu. I'm software developer. I'm working for UFAC, Observatoire des Forêts d'Afrique Centrale, in English, Forest Observatory of Central Africa. Okay, I will present the background of OFAC. OFAC is a technical and scientific body of the Commission de Forêt d'Afrique Centrale and Central African Commission Forest. The role of OFAC is to provide the up-to-date and relevant data on the region forest and ecosystem, aimed at informing policy making and promoting the better governance and sustainable natural resource management. We are working with 11 countries, and we are based in Cameroon with COMIFAC, and we are also working with the national coordination COMIFAC of each country. The key part of the COMIFAC is a convergence plan, which is a strategic and policy document which define the milestone or how we have to best manage our ecosystem. The principal role of OFAC is to ensure the permanent availability of information on forest system. Now, how are we working? The OFAC is like a decision support system for Central African forest ecosystem. We are working at 4 regional scopes or 4 regional level. We are collecting data at regional level, which concerning the 11 countries. We are also collecting data on landscape, which is focused here in transboundary conservation of areas. We are also collecting data on national level and local level. Local level here is forest concession and unprotected area. Well, how is our methodology? How are you proceed? We have multiple thematic at multiple scale. Our approach is bottom up and top down with combining field data with Earth observation products in order to have a better support for decision making. We have two principal kind of thematics. We have the main thematics and emerging thematic. In the main thematic, we have 5. We have a forest cover. We have a legal and institutional framework. We also have a managing of forest or forest exploitation. We also have the thematic on the biodiversity and climate change. We also develop the emerging thematic like green economy, knowledge-based monitoring, and developing territory and transhumance. In the right schema, we can see how we are proceeding. We collect data bottom up and top down. Down here, you can see that we are collecting data at the country level and the local level. All data are analyzed through the OFAC, and this data can be transformed as information and sharing to the policy making. Now, what our products? All data collected now can transformed and diffused like of our information system. We have many reports and policy brief like state of forest, like a state of protected area in French and English language. We also have our web mapping analytic platform which is based on the web mapping interface. So this analytic platform, all the user can access to of the data which are collected at different scale. The user can visualize our geospatial database, make analyze and multi scales. We also have many kind of maps and monitoring projects on method. To our system, you can have the maps concerning the integrity of protected area, integrity of forest concession, the states of transhumance in some country of Central Africa. Well, that is some kind of products which we have, where we are combining the data field with the Earth observation products. In these products, we are producing the new regional forest type maps in Central Africa. How are we working for this kind of product? We are working with some focal points on each country, because you know that in Central Africa, the forest context is not the same in all the country. We have to make some harmonization in order to have a best understanding of our forest type. Now here we are combining we are using Earth observation products like Planet, like Sentinel 1 and 2 in order to produce this kind of map. We also produce the map of integrity of protected area or concession forest. So of this kind of Earth observation product, we can also identify some illegality product in the protected area or in the local seat. Concerning the landscape, we are processing multiple satellite images during 20 years in order to monitoring the level of water, the land use cover, and stock of carbon in the key landscape. Now, how are we proceed? What our principal outcome or output? OFAC, we can see OFAC like information brokers, which provides information services to support data survey-based decision for the sustainable management of Central Africa forest ecosystem. We have multiple database and the geospatial database, which is combined in order to develop or to provide a better decision-making tools. Our expected outcome. Now we want to develop a strengthening of the spatial component in order to have the more expensive support for field operator by developing target information services. We also want to have the diversification of information products like charter, like policy brief and other. We also have to have a multi-sectorial territory approach in order to monitor the new thematic which can have a direct or indirect impact in the forest or biodiversity. So how are we collaborate? Under the supervision of COMIFAC, OFAC benefits of the support of European Union to the RioFAC project and Biopama program. And OFAC implements a series of partnership with international institutions like ATIBT, FAO, WCMC, in order to ensure the sharing of the information from the field to the global convention, vice versa to the national and regional organization. The OFAC is at a heart of information change at the Central Africa for better information decision making. Many thanks for your attention. If you have any question, at your disposal. Thank you.
Thank you very much, keeping it within the 10 minutes. So we'll go into the next presentation straight away so that we try to get the few minutes that he has saved us. We are looking at the next presentation is on using remote sensing to detect irrigation practices in the Kumanko farms by Delisa Didiza from, wow, the pronunciation, Kogazo Innovations. I'm sure you'll pronounce it well. Welcome.
Maki, is it Maki? Good morning in Twi. Someone please help me out. Machi, thank you very much. Just waiting for presentation. Excellent. So my name is Delisa Titiza. I am the founder and director of Khotatso Innovations, pronounced Khotatso. It's a Tswana word for motivation. I am also the co-chair under AfriGEO for the Agriculture and Food Security Community of Practice. I'm more here in that capacity. However, I'm hoping that from what I share with you today, you can see the relation between Khotatso Innovations and the work that we do within the communities of practice. Just to touch a bit on my capacity as the co-chair. So we look after the agriculture, and as I said, agriculture and food security community of practice. And within that, one of the objectives, we have a few objectives as the COPs. I'm sure some of you have heard about the COPs. And one of the objectives that we have within there, which touches on this presentation this morning, is how we can improve existing mapping capability to improve land suitability when we're looking at agriculture and assisting the users within the agricultural spaces. and also to share EO data and tools to support these agricultural applications. So those are the main objectives that you'll see as I share with you this morning, that I'll touch a bit on, that this presentation will touch a bit on. On the Khotaste side, I've shared that we are a GIS and remote sensing company, whereby we help clients with making more informed location-based decisions within their various fields. And this could be in both public and, the government space. In terms of what I'll be covering this morning, that is what is in front of you. I won't go through each and every item, just to be sensitive for time. So I'll jump right into, I'm hoping you can make out, as specialists within the location intelligence space, we always like to know the areas that, we are sharing with you about. So from the first map, if you can see the numbers on the maps, that's the whole African continent, our beautiful Africa. I'm not sure if you are able to see the little arrow that shows Ghana, where we are, versus South Africa, right at the southern tip. And then we drill in a bit and we show the whole of South Africa, and you can see the provinces, the 9 provinces that our country is divided into. And we've got the Eastern Cape, where this study was conducted. And then as we go into the Eastern Cape, we've got the various, am I pointing? Maybe I should point. How do I point? Okay, I don't know how to point. We've got the various district municipalities. The specific one for this project was the, I beg your pardon, not Pumango. It was the Chris Hani District Municipality, which has got 8 local municipalities. These are the smaller municipalities within it. And within that, in the green, the second last picture, you can see the small municipality of Intsika Yetu, local municipality. That's where the study took place. And of course, just zooming in a bit into the local municipality, you can see Kumango, which is our study area. I must mention that Eastern Cape, for those of you who don't know, is where the legendary Nelson Mandela comes from. In fact, this study is very close to his area where he grew up. So Pumango, just to give you some background in terms of the project itself. So in South Africa, as I'm sure in other countries as well, we have what we call the National Water Act, because it is a dry country. And we do need to make sure that our resources, for example, water, are sustainably managed. And that's where now the Water Act comes in. I won't go into the details of it because for this study, we were not required to, to study the act and know what it is. However, so the Water Act then gives rise to what we call the water use license, which will, you have to apply for it in order to make sure that whatever water use that you're going to have for a project such as this one, you will have enough water for it, and also you will not be abusing the water resources. So in this case, just a bit on the Kumango area, it's a rural area. As you can see, I'm hoping that this map on your screen is a bit clear. It's a rural area. Mostly they have on the western side, there's a bit of commercial agricultural practices. On the eastern side, where our area of study was more of the rural areas where you'd find most of your communities that practice subsistence farming. And also, there would be obviously taking this to the commercializing this as well. In terms of services within the area, they're quite limited, and this speaks to the municipalities and their capacity as well. You'd find that some of the backlogs would include delivery of tap water and adequate sanitation. Yes, in 2021, well, when the study was happening, we're now in 2022. And of course, so you find that within Kumango, the communities, they get the water mostly from, you know, unprotected springs, streams, and even some boreholes, while the commercial farmers extract water more from the boreholes. So in terms of the project itself, the Kumango Agricultural Development Company, with the support of Exaro, which is one of the major mining companies within South Africa, they started this project because they want to do an agricultural hub of about 3,000 hectares. Now you can imagine 300 hectares is going to use quite a bit of water. And so this project's aim is to, because we are hopeful that it will continue so that everyone can benefit, was to produce and commercialize commodities such as maize, soya, beans, and some fodder crops. And of course, for a mining house like Exaro that has got people that come from these communities, this is part of their way of saying, you know, this is us contributing to the communities where our people come from that work within our mines, etc. So what was the issue? If you recall, I touched a bit on the water use license. So one of the things that the Act says is that the national government is there to be the custodian for all the water resources. However, the local municipalities need to be the ones that actually provide the services, the water services to the communities. But there was no data, or you'd find that there's little gaps here. The community will say this, the municipality says this. Was this area irrigated? Because the Water Act, again, will say that if it was historically irrigated, then we don't need to apply for a water use license. But if it wasn't, then you do need to apply for the water use license. So there was not enough information. And unfortunately, that is the case within a lot of our municipalities. We don't have, there's a poor record of data that should be used for decision making. And I think that's one of the things that we are actually coming across a lot quite in this symposium. So firstly, that's the statement of the problem. That's what we had to determine. Was this area, did it have an existing water use license? Was it irrigated, and when? So in terms of the objectives, we needed to then determine if the area was irrigated, and if so, when. I've just touched on that, and whether we do need a water use license. One thing I forgot to mention earlier is that a water use license application can take up to 8 months. Now you can imagine this is a community that can't wait to get this project started because everyone is going to benefit from it. Now, you know, if there is an existing water use license, then there's no need to apply for a new one. There's no need to wait. They can start commercializing and making this land productive, you know, today. However, if they do have to apply for a water use license, there is going to have to be that wait. So in terms of the methodology, I'm not going to bore you too much about those details. I worked on this project with one of our people, a young gentleman who also went to the same university where I studied, the University of Forte. And we came across, after obviously assessing what needed to be done, we decided that this would be our approach in terms of the methodology, whereby we would be using Landsat 5 imagery, which you know is very good when it comes to vegetation studies. However, the main thing when it came to the methodology, remember with determining irrigation, there's the rain that would do the irrigation for the area. So we needed to be able to differentiate between that kind of irrigation versus the man-made irrigation, if I can call it that. So we used the vegetation condition index, which according to literature is the best for this kind of study. And of course, we had to consider the seasons and the rainfall. And we took that information into account as well. And as you can see, after the land classification, then we now left with irrigated lands versus rain-fed lands versus uncultivated lands. So this is just to share with you the results. So the black boundary is the actual 3,000 hectares that we're looking at, but we kept the area slightly bigger just for comparison purposes. So this is, we're looking at the year 1996. The study was between 1996 and 1998. And the reason for that is because the Water Act came about, was effected in the year September 1998, if I'm not mistaken. So this is just to say some of the results. I won't go into too much details. We also, of course, took into consideration the land surface temperature, a bit more on the results, and that is the final area that we're looking at. So the blue is actually the area that was irrigated. And out of the 3,000 hectares, only about 38% of it was actually irrigated. And we discovered that the irrigation took place between 1996 and 1997. So what did we conclude? What did our findings tell us? It answered the question whether the irrigation happened or not. Yes, it did. And the effect that the water use license application would therefore be necessary because the area that was irrigated was quite small. But what does this mean? It means that now this project is not at risk. It is compliant because it protects all that needs to, for this project, that needs to happen for this project to protect our resources can be done. The WULA can be, the water use license application can be done, and the community will be able to have a project that will not be shut down should they decide to continue, and everything is compliant. And then just quickly, those are some of the areas that we saw as areas of proposed applications. And that's mostly your environmental practitioners who do quite a lot of these water use license applications. It's communities, mining areas, or other mining houses, and our municipalities, because they need this information for decision making and to make things easier on their side as well. And before I get chased off the stage, these are the companies and the organizations and the people that I would like to definitely thank for making this this project possible, and also the presentation and the trip to Accra. Thank you.
Thank you very much. I think we take the opportunity during tea break to hear more about the results. I think that's the part that we've probably not gotten in detail, but the background is very interesting. Thank you very much. So we'll go straight into the last presentation of this session on climate intelligence by Niels Hemperman from the Open Geospatial Consortium. And welcome.
Thanks a lot for the opportunity to speak here, and thanks a lot also to have the presentation scheduled here. That originally it was scheduled yesterday, but due to an overlapping other session, that we have to put that here. Climate intelligence has two meanings actually. Some of the persons are connecting that with the translation of data, climate data or raw data into information. That could be climate intelligence. And the second one is the implementation or the usage or enhancing climate services with artificial intelligence. In this case, that both is valid. And I try to pass you through on the Open Geospatial Consortium, what we're doing there in terms of the climate resilience. Here are some information. Here are some projects where we are involved in. That's just an example. The Open Geospatial Consortium is a member-based organization, so we have more than 500 to 600 members with a lot of experts inside, so quite a large number of people, and with that we can conducting quite a lot of different projects. And if you would like to check out more, then have a look on the website. In terms of technology that we are covering, so from the conceptual start, just setting up the concepts, up to the readiness or the interoperability experiments in between. So, and the projects also are covering small things, short, just coding sprints, pilots for a couple of months, up to multiple years initiatives. So according to the need, we are doing whatever it's necessary. And one of the main principles that we are following is the FAIR principles, is findable, accessible, interoperable, and reusable. That's basically kind of the main core, and where we are working around, because in terms of the data, in terms of the APIs, in terms of the services. And recently we set up a new working group on climate resilience, so that's brand new. This is chaired by ECMWF, so the Climate Change Service, E3S, and then the colleagues from Natural Resources Canada and the Ordnance Survey. So that's a very nice combination, international combination, and you're very welcome to join this working group. In the charter, it is written that we are following the FAIR principles and how to tailor climate resilience information systems in a way so that they are interoperable. So we have heard that necessity multiple times, well, yesterday, today, and the target is always that we are kind of following the needs on the United Nations policy frames. So bridging the gap. There was a nice picture in the previous talks between the data and service providers and the users on the other side. Sorry for the busy slides. It's a little bit tiny, but here you can see also how we have it designed. So there is the data and service providers on one hand, so the stakeholders, and then the stakeholders on the other side. And then in the combination, we have the climate resilience domain working group as a think tank, as a platform together on that virtually, and then also 4 times a year there are the member meetings, so also physically, where we're exchanging information. And then in parallel to that, and that according to or depending on the available budget that we get from sponsors, that we are able to conduct climate pilots. And the first one is currently out, and we are running that. So there is a call for participation out. So if you would like to participate, submit a proposal if you want. The deadline is at the 18th of November, and next week, the 8th, we have a Q&A, question and answer session on that, because the details are on the website as well, if you are interested in that. And then we are selecting the good proposals for sure in accordance to the sponsors. And then next year, in the beginning of January, we're starting with the first pilot, talking about climate resilience, information systems about the backends, and how to deliver good information to the stakeholders. It is planned to have it as a multiple year initiative. So that's not only one project, that's not only one pilot, we're running that over multiple years. So it's anyway a good idea to get involved in this domain working group, even if you're just an observer, that's already a good way. That's what we are always facing. Like I said, on the left hand, you have a huge amount, massive data, and then even if you are living in a good internet with good internet connections, that it is impossible to download all that. So it's necessary to move the algorithms to the archives and have processing services there. So doing that in cloud and high performance computing services environments, and produce the appropriate information that is necessary then for example, the policymakers or also the scientists to have science services, which is then high level information, but small in size, fitting through the internet, and you can then take it and use it. That's on the technical level, and here comes the ideas of OGC, of the Open Geospatial Consortium, of tailoring that to the FAIR principles. That means that once someone wrapped up a good algorithms into OGC APIs, for example, and that then it is reusable for anybody who would like to have that in their climate resilience information systems as well. And on the left, on the right side, and it's also being bridged by the appropriate data visualization and the targeting then different user groups according, the visualization is then according to the user group. So with interfaces very complex for the scientists or very simple for someone who is probably not so technically organized. And we are not starting from scratch, so that's there's a long experience and that already behind. So there are climate resilience building blocks, how we can name that. So that's what I'm showing here is all available as open source, but then you can also add your proprietary software to that. That, for example, there's also a building block on hydrology, that with hydrological models inside, or climate indices. And then currently we are now starting to ingest also artificial intelligence into that. That's what I'm saying here, that's a project from the European Commission and that about climate intelligence, CLINT, with a very large scientific community, and the OGC has the part that we are wrapping it up into an OGC API processes, which is, without going into technical details, a way that you can trigger and process from